Hi everyone, Abdul here from tekki, and today we're going to talk about the graphical modeler. See, the graphical modeler in QGIS helps us to create workflows that can handle automatic and semi-automatic calculations or analysis. This way we ensure efficiency, smart work, shareable expertise among others. So, an example is that we recently posted videos on mapping groundwater vulnerability, and you could see we were repeatedly clipping, projecting, reclassifying, and whatnot. The good news is that Graphical Modeler can help us create a workflow for all or most of these actions. Here's a simple example of what it looks like. Here, for the depth water, we will go from selecting our DEM, clipping it to our study area whilst handling the projection simultaneously. Then we will reclassify the results, and finally to outputting our reclassified depth to water. So let's get started, and if you find this helpful, support us by subscribing, liking, and sharing. Also comment down if you have any questions or ideas. Now, to open the graphical modeler, we come over to our project and then you head to the processing toolbox. The first two at the top here, these small gear icons, you click on it and then you can create a new model from here. When you have a model, you can open it by coming here as well, or you can even add a model to the toolbox in here. Anyways, let's go ahead and click on create new model. This is what the interface looks like. In here, we are going to add our model, which will build like a tree. And we'll be using this run tool to test it and also to run it. And then these are some few navigation tools. And over here, we have the file management tools. Now to the left, we have the inputs and algorithms. The input will help us input anything that we want, from raster layers to vector layers, CRS, booleans, databases, etc. Now with the algorithms, this is just a replica of our processing toolbox. This is where we're going to pick up every single tool that we need to work with. Below that, we have the model properties. So we can enter the name for the model and the group it belongs to. So for the purposes of this tutorial, we're going to work with the depth water and topography, which were the two videos that were ready at the time of the recording of this. So we're going to call this BT, as in depth water and topography. This is because we are going to see how we can create model for the both of them and connect them. Now the group, we are going to call this Drastic, since that is the name of the project. So below that, we have the undo history. This is where we will see whatever that we have done yet. So if you add anything or remove or shift, whatever that we do, we can see it here. When this build up more intense, we can always roll back by going to a previous state that we were in. It's super helpful. Now, to get started, we'll come over to our inputs, and we are going to start off by selecting an input for our raster layer, which will be our depth to water, and then we will input our vector polygon. So let's come here, inputs, and scroll down till you get to raster layer. Let's pick this up. You can double click to open it, or you can just pick it up and drop it on the canvas. Now we are required to enter a description. I'll just call this choose DTW for depth to water. Now you can make this as simple as you like. Just ensure that it's readable, you can understand it, and if you are sharing this, you need to make it more understandable, of course. So when you're done that, you click OK. You can always pick this up and move it anywhere you want, and you can also hover on the edge to be able to resize it however you want. To clear this, you can click on it, select it like this, and you hit delete on the keyboard, or you can go to the top right and click on the X button here. You can also edit by either double clicking it like this, or by coming down to these three dots and just make a single click, and you can be able to modify anything that you want. Now let's go back to our inputs once again and then look for vector layer. So here we have vector layer. Let's double click, and then we're going to call this our AOI for area of interest. Now leaving this geometry type blank will still work perfectly fine, but how about we just change it to our polygon type, since we know this is specifically what we are going to be working with. So let's click OK. Now you see we have our raster layer and our vector layer. What are we going to do next? We're going to see how to perform clipping. Now, just to give you an idea, in case you haven't watched this video yet, which is what we are basically building this model on, we're going to perform clipping to extract a version of the depth water for our study area. From there, we're going to make sure we check our projection and everything, and then we see that we have to reclassify it. So we perform the reclassification here as well, and once we are done with that, we're going to multiply the result of that by 5, which is the traditional weight value for depth water. So basically, we're going to do a lot. Just follow along and as we go. So now we're going to come over to algorithms, and you can always search from here, which will make it super easy for you. So let's search for clip. Now under GDAL raster, we're going to pick clip raster by max layer. Double click to open. This is where it gets interesting. So under the properties, we're going to change this description. I'll just call it clip depth water. Now under the input layer, you see we have value, pre-calculated value, model input, and algorithm outputs. We're going to choose model input, which basically refers to every single input that we put onto the model from here. Now, because this input layer naturally is going to be a raster layer, that's how come we have choose depth water already selected, and we cannot change that because so far that is the only raster layer here. The same applies to our max layer, which is going to take our vector polygon. Now the other thing we need to do is under our target CRS, you can click use project CRS. This way, if you're working on a particular CRS which is associated with your project, this is the exact same CRS that is going to be assigned to your clipped raster layer. The other thing you can do is uncheck this and then specify what you want by coming over to this projection icon here, and then from here change to predefined CRS, and you can pick whichever one that you want depending on the project you're working with. Okay, now the other thing you can do with this as well is to double click it so you can go back and change certain things. So let's scroll down a little. Under the target extent, let's set this to our area of interest. So you choose model input, AOI will be selected, and then we're going to leave this blank because we just so super sure we're going to have very good output. But it's something you can play with if you ever do, depending on what you're doing, if you're encountering problems. Scroll down here, and under the clip marks, we are going to enter a name here, which will now specify whether or not we are exporting our results. So let's enter clipped depth water. This is just for an example sake. You can see now we have sort of orange colors, which are always for the inputs. Then this gray is always for algorithm, and when it's green, that is for an output. So how about we test that before we continue? So let's put this aside and hit run. Now our AOI is already selected because it is opened here on the project. Now we have to choose our DTW. So let's click on the ellipsis and navigate to where we have saved our depth water. All right, that is here. So pick up your depth water. We're going to save this temporarily. So let's click run. Close. And you can see this is our depth water clipped. So if you hover over it, you can see the projection here is set to what we specified. All right, so let's get rid of this and go back to our model. The next thing we're going to do after this is to reclassify our layer. To do that, we go back to our algorithms, and here we're going to search for reclassify. So let's click on reclassify by table. Now, if you have already watched this video, you understand exactly what I'm going to do here. just for the sake of those who have been, what I'm going to do is break our data into several ranges and assign new values to them. This is what reclassification is all about. So, but first of all, under raster layer, we're going to make sure you change this to algorithm outputs. The reason is that now we're working with clip DTW, which is an algorithm that gives output and not an input anymore. So once you do that, ensure that it is checked in case we have several algorithms. So ensure your appropriate one is checked and then leave the band number to 1. And then let's go over here, click on this ellipsis so we can enter our values here. So I'm going to add 6 rows and quickly enter the values like that. And finally, we have 450 to infinity. And then we're going to give that 1. Click OK. Now we're going to enter a label here just so we have an output to see how it goes. So let's say D rated. Click OK. Actually, let's change this label or description. So reclass E. Hit OK. So let's go ahead and run this. Hit run. Close. And everything is still okay. Now, if you look at this, actually, we have this sign indicating that we have some problem with projection. So what I'm going to show you next is how to assign projection to an algorithm or an output that you're expecting. There are several ways to do this. You can have an input of a defined CRS and then you can always call it to the algorithm. But what I'm going to do now is come over to algorithm and then we're going to search for assign projection. And under GDAL, I'm going to pick up the raster projections. So assign projection, double click it. So quickly I'm going to change this description to PRJ. And under inputs, we're going to switch to algorithm outputs. So we're going to check our reclassify D. So click on this and change to reclass D. And then we're going to choose the CRS. So let's just use the project CRS and click OK. So let's get rid of this for now. So this projection that we have is going to be assigned to our reclassified layer. Now the next thing is for us to now multiply this by the traditional value, which is 5. So to say, we are now going to perform raster calculations. So let's search for raster calculator. Pick the one on the GDAL. And what we're going to do is first, let's call this calculate BRDW. I'm going to change from inputs to algorithm outputs. The output is going to be the reclassified D. So let's make sure we have it selected and then put 1 here. Now to explain, we have input layer A, which is, so to say, the raster A. Let's see, we have raster B, raster C in that order. So this each field with the corresponding alphabet can take a single raster layer at a time. So if we are working with several raster layers here, for example, say we wanted to add up several raster layers, we're going to select one of them in A, assign the band value, then choose the next raster in B with the value in that order. But since we're just going to work with one single raster layer against a number, we're going to leave it like this and then scroll down until we get to where we have to enter the expression, which is here, calculation in GDAL numeric syntax. So what we're going to do now is change 2 to 5 since our traditional weight value is 5. We can scroll down more and enter a name for our final output. So I'm going to call it DRDW and click OK. One thing I want to show you though is how to work with dependencies. Now, dependencies simply means even though we have this sort of workflow going down and it should execute hierarchically, we need to sometimes specify and ask some algorithm to wait until something else is completed before it can start. Now, what do we mean by that? To perform clipping, we knew we needed these two layers. Yes. So after clipping, we are saying we want to reclassify. Now, before reclassification can happen, we must be able to clip this. Now, the only problem is that sometimes when we have outliers like our projection, depending on how complex you are building the model, it could actually, this tool here, calculation for DRDW, could actually pick up the results here to run with sometimes, even when we don't have our PRJ assigned to it. This is just a scenario base I'm creating. So to make sure we have everything working out well, we want to go back into our calculate DRDW and then ask that it should wait until this projection is assigned. Oh, sorry, and wait until this projection is assigned to our reclass B before it can pick up the result from there to do that calculation. I hope this is clear. So let's go back into calculate the RDW. Scroll all the way down until we get to dependencies here. So let's click here, and then you can see all of the processes that we can ask to execute fully before we start the calculation. So I'm going to check PRG, click OK, click OK. Now we see we have a connection to that. And this time around, it's not coming in, as you can see here. It's actually an arrow to say this has to be performed before we can now proceed with this. And let's go ahead and run this whole model once again and output our final results. So everything is still checked. Hit run and wait. So it's done. Let's close this, and you can see we have it right here. No troubles. Everything is in place. So as far as D is concerned, this is how we derive or build a model to perform every single action whilst we are sitting with our fingers crossed. The same way as we have this flow, I'm going to do another one for our T or topography right here, and we can see how to link them at the end of the day. So we're going to come over to our inputs, and we are going to add a new raster layer, which will be for our DEM. Let's go back here, double click raster layer. So we're going to call this DEM, or choose DEM, hit OK. You know already the thing we're going to do is get our area of interest to perform clipping. But what we can actually do is reuse this AOI. In other words, it is unnecessary to create an entirely new vector polygon here for our AOI. So we're just going to grab our algorithm for clipping. So clip by max layer. Let's call this clip DM. And for the inputs, going to now come over here and choose you know, the word play. We are going to choose the all right. Now under the max layer, of course, it's going to be our AOI. You see why this was unnecessary to create another one. I'm going to do the same thing with targets CRS. So here we can choose projects just to pick the projects coordinate we have existing. I've already explained this, and then just click OK. All right, I just mistakenly deleted that. So you can Control Z, or you can come over here at our undo history. So when we were doing the resizing, let's just click this to get it back. Now, when we clip our DEM, we want to take the result. This time we are not rushing into reclassifying. We want to make sure we change it into slope and express it as percent. So we come over here, algorithms once again, and we're going to search slope. And the GDAL raster analysis, we pick up slope. We're going to maintain slope as a description. Now under inputs, remember this is model inputs, and we're going to be working now with an algorithm which we are expecting an output. Click DEM. So change this to algorithm output and choose clip DEM over here. Band number is 1. And most importantly, under slope expressed as percent instead of degrees, we change the boolean to yes. Now, I do skip some of these other options because without them, we're still going to have our result. Now, depending on what data you have, sometimes you need to perform stuff like compute the edges and calculator, etc. That sort of thing. Anyways, once we have this, how about you just click OK? Now, what we're going to do next is perform reclassification like we did right here. We've come over here, reclassify by table. And if you have been following this series, we have this table that sometimes we use for our reference ranges over here. So this is our topography. We're going to be using these ranges to work with. So here, first, let's change to algorithm output. Change to slope. So we choose slope, band number 1, and then let's create our table. There's going to be 5 of them. Once again, I'm going to enter the values and we continue. Then we have 18 and infinity, which we will rate as 1. Now click OK and OK. Now we have our T rated. As you know, the default weight for T is 1, and when we did this video, we mentioned that retaining T like that is automatically our T rated and T weighted. So this is automatically our TRTW. But then let's just, perform the raster calculation. So let's search raster calculator. So we're going to choose algorithm outputs. We're going to enter our class T. Band value should be 1. Scroll down. We multiplying A by 1. And we outputting the value as TRTW. Hit OK. Rename this. Calculating T. Hit OK. This is our TRTW. All right, now we're going to run this, but before we do that, I'm going to set another dependency here. So we assigned a special reference system to our reclassify T before we perform this calculation. Assign projection. So this is going to be the projection for T. We need to make that distinction, and then we need to change from input to algorithm output, and we're choosing our reclass T, and we're using the project CRS. Here, okay. We'll come into calculate T, scroll the way to the bottom, under dependency we click this and then choose our projection for T. Hit okay. Hit okay. So let's go ahead and then run this. In case it doesn't work well, we can come back and then check what is happening. And you see, we need to choose the appropriate layer for choose DEM. So let's come over here, click Ashanti DEM, click run. Close this. You see, we now have our DR, DW, and our TRTW. Now we are not quite done yet. In the beginning, we said we're going to see how to now connect our D and our T. So the final thing we do before we get out of here is to pull up another one, which will be an algorithm for raster calculator. So let's search raster calculator here. Here, let's calc DI. So here's where I was mentioning So we now have to work with more than one raster layer. So what we're going to do is, for our first input layer, we're going to check algorithm outputs and then change this to our calculated DRDW. One value should be 1. So for our input layer B, we switch to algorithm output as well and change this to calculated TRTW. One value is 1. So let's scroll down. This time around, we are going to add A to B. And you can enter in the name here. So this is DI. Click OK. And if we do run this, we will now be arriving at our DI. If we had to work with more than just these two, it still be the same way. You just have to specify the other band values or the other layers under the other fields that we could add more layers or more raster fields. There you have it. I have broken down how to navigate the graphical modeler. What we did was a lot. We saw how to add and remove layers, how to perform clipping, projection, reclassification, raster calculations, a lot. We also look at dependencies and how to assign projection, how to now output your result, etc., how to reuse layers, a lot. But there is still even more room to cover. Anyways, I hope this is helpful, and if you do have any specific concern, you can comment it down below. Also, don't forget to subscribe to help us. Subscribe, like, share, and I'll catch you the next time.